Yes, welcome in the chemistry class. That is the interpretation of IR absorption spectrum. But before we look at the interpretation of the spectrum produced by IR, we need to know the corresponding values, or that is the wave numbers or the frequency that corresponds to a particular spectrum. So as we all know that the IR spectrum will always give us a particular functional group. So in interpretation, we shall interpret the spectrum from the higher in order for us to determine the functional group which belongs to a particular compound or which is present in a particular compound. So the higher spectrum will always give us a specific functional group. So now we can have more than one functional group within a particular spectrums or the spectrums produced. So to begin with, we are going to look at the first one, that is alcohol. So in our IR absorption correlation chart, we have around 4 columns which I have made. The first column will give us the functional group. The second column will give us always the types of vibration. And the third columns give us the absorption frequency, or we can call it as the wave number, that is per centimeter. Then the last column will give us the intensity. So in alcohol is our first compound here. So in alcohol, we have to know which functional group will always give out spectrums, or the one which we can easily read. So in alcohol, we have the OH functional groups, and then we have the carbon single bond oxygen, which will always give out the spectrum. But now in OH spectrums, we shall always have two kinds of spectrums. We shall have the spectrums produced by the OH group. That is when there is formation of hydrogen bond. Then we shall always have the spectrum produced by the OH, which is produced when there is no hydrogen bonding, that is free. Free means that there is no formation of hydrogen bond. So the OH groups will always produce vibration, that is a stretching vibration, but it is always affected by the hydrogen bonding. Now the formation of the hydrogen bonding will always lead to the decrease in the frequency or the absorption frequency. So the absorption frequency for the OH functional group, that is when there is interference by the hydrogen bonding, we shall always have the frequency range around, that is 3,200 to 3,600. This band will always be strong and broad. Then we have the OH functional group when there is no hydrogen bonding, that is free. We shall always have stretching frequency, that is stretching vibration. And the absorption frequency is higher than that of the OH group, or that the one which is produced by the OH group when there is hydrogen bonding. So here we have the OH, that is the frequency or the absorption frequency ranging from 3,500 to 3,700. Here the peak is always sharp and very strong. Then the carbon oxygen or the carbon single bond oxygen in the alcohol, it will always produce stretching vibration, but the absorption frequency will always range from 1,050 to 1,150, and the intensity here is always very strong. So that is all about in alcohol. Then when you look at the carboxylic acid, in carboxylic acid, we shall always have around 3 functional groups which will always produce vibration that leads to the absorption frequency or the absorption spectrum, produces around 3 peaks which are always recognized. The first one is the carbonyl functional group, that is carbon double bond oxygen. It produces the stretching vibration, and here the absorption frequency always range from 1700 to 1725, and the intensity is always strong. Then when we compare, we have OH functional group in carboxylic acid and OH functional groups in alcohol. Then what will distinguish them will be the size of the spectrum being produced. So here the vibration is stretching vibration. Then the intensity here, it is very strong and very broad compared to that of the OH functional group in alcohol. That one does not produce very broad band. So the one in carboxylic acid is always very broad, it is very large. So when you look at the range of the absorption frequency, it ranges from 2,500 to 3,300, which is having a range of almost that is around 100 or even 1,000. Oh, when you subtract, that is 2,500 from 3,300, you may find that you have a very big range. So making the bands produced or the spectrum produced by the OH group of the carboxylic acid to be very broad. Then we also have the carbon oxygen functional group, which is also present in alcohol. So this one produces stretching vibration, and the range is from 1,210 to 1,320. So when you compare, this one is a little bit stronger than that of the carbon single bond oxygen in alcohol. And then the intensity here is strong. The intensity produced by the carbon oxygen vibration is strong. Then if we go to the carbonyl compounds always have the carbon oxygen, that is carbon double bond oxygen, and it produces stretching vibration. Here the absorption frequency ranges from 1,670 to 1,820. So meaning if you look at the peaks which lies within this range, that one will be the C double bond oxygen, that is the carbonyl functional group, which is the same as that of the carbonyl functional group in carboxylic acid. But for the carboxylic acid, has a range from 1,700 to 1,725. So this one ranges from 1,670 to 1,820. And always the intensity here is very strong. Then when we look at, if we look at that one of still aldehyde, the aldehyde is still a carbonyl compound, and it has also the carbon oxygen bond, but it is a carbon double bond oxygen. So this one also produces a stretching vibration. Then the absorption frequency for the carbonyl functional group of aldehyde, it ranges from 1,740 to 1,720, and here the intensity is also strong. Then in aldehydes also we have the carbon hydrogen bond, which will always give out spectrum. So in general, in aldehyde, we shall always see the carbon hydrogen spectrum and then carbon double bond oxygen spectrum. So for the carbon oxygen spectrum, we said here the absorption frequency ranges from 1,740 to 1,720, and the intensity is strong. Then when we come to the carbon hydrogen bond, this one produces a stretching vibration, but we shall always have two peaks. One will always be at, that is within the range of 2,820 to 2,850. Then another peak lies within 2,720 to 2,750. And here the intensity is not strong. The intensity is always medium, and we said that we shall always have two peaks, and the two peaks are indicated by the absorption frequencies. Then we have the hamide. Hamide consists of two functional groups, which will always give out the absorption frequency, produces two peaks. So now one of the peaks will be for the carbonyl functional group. Then another peak may be for the nitrogen-hydrogen vibration. Then we shall always have nitrogen-hydrogen bending, also the vibration produced by the nitrogen-hydrogen, but it will be a bending vibration, not a stretching vibration, meaning for the bending vibration will always lies in the fingerprint region. That is a region around 1,550 to 1,640. This one, anyway, this one, it is just nearer to the fingerprint region, but it is not within the fingerprint region, it is above. So the carbonyl functional group of the amide produces a stretching vibration and has absorption frequency within 1,640 to 1,690. That is having a very strong, that is strong intensity. Then the nitrogen hydrogen, one of it produces stretching vibration. Then another peaks will be produced by the bending vibration. Then the one which is produced by the stretching vibration ranges from 3,100 to 3,500, and this one will always be unsaturated, and they always have two peaks or the two bands. Then we said another bands will always be at 1,550 to 1,640. That is produced by the bending vibration. So in hamide, we have the NH bonds, which give out two bands. One of the bands is produced by the stretching vibration, and another band is produced by the bending vibration. So now the nitrogen-hydrogen bonds that produces stretching vibration has an absorption frequency ranging from 3,100 to 3,500. Then another one which produces the bending vibration has the band or the absorption frequency ranging from 1,550 to 1,640. Then we have anhydride. Anhydrides also contain the carbonyl functional group. This one produces a stretching vibration, and the absorption frequency here is having a range from 1,800 to 1,830. So there are always two peaks for the hydride. One of the peaks still for the carbonyl functional group. In anhydride, it has a range from 1,740 to 1,775. So the two bands lies within these two ranges. Then we have an ester. An ester will always have two kinds of functional groups, which we can sometimes identify. We have the carbon double bond oxygen. It produces stretching vibration, and this one gives out absorption frequency within a range of 1,735, then that is to 1,750. And this intensity is always very strong. Then when we come to the carbon single bond oxygen, still for an ester, it produces stretching vibration. And this stretching vibration will always have the absorption frequency ranging from 1,000 to 1,300. So this one lies within the fingerprint region. The fingerprint region will always lies from 1,400 downwards. So it always gives out two bands, that is two or more bands due to overlappings. Then we have an ether. An ether is having carbon single bond oxygen, and it will always produce stretching vibration. Still, it has a range from 1,000 to 1,300, and the intensity here is strong. Then if we move to another one, that is the nitro compounds. The nitro compounds will always have nitrogen double bond oxygen. It produces stretching vibrations. So the stretching vibrations here give out two kind of absorption frequency, or the two peaks. So we shall always have two bands. One of the bands ranges from 1,515 to 1,560. Then another bands have a range of, that is from 1,345 to 1,385. So the intensity here is strong, and we said that two bands will always be produced, and the two bands have these two ranges. The one is at 1,515 to 1,560. Then another one is having a range from 1,345 to 1,385. Then we have the nitrile. Nitrile is having carbon triple bonds nitrogen. The presence of the triple bonds will always affect the kind of vibration or the absorption frequency, because the triple bonds will always produce higher absorption frequency. Here, there is always stretching vibration. The types of the vibration produced by the nitrile compound or the nitrile functional group is the stretching functional groups. And the absorption frequency ranges from 2,210 to 2,260. So here the intensity is medium. It's not strong and not weak. It is medium. Then we come to amine. Amine is having the NH functional group, and it will always produce stretching vibration. Now, this stretching vibration produces the absorption frequency within the range of 3,100 to 3,500. And here it is medium. So the vibration produced by this amine is always given out by primary amines by giving out two bands. Secondary amines will always give one kind of band, and it is often very weak. Then for the tertiary amines does not produce any peaks because it does not have nitrogen-hydrogen bond. All the hydrogen has been replaced by other alkyl groups or other atoms. So we shall not have any peak or the spectrum produced by the tertiary amine. It is always given out by primary amines and the secondary amines because they are the one that contain nitrogen-hydrogen bond. Then we have also in amine still we have the carbon-nitrogen bond. The carbon-nitrogen bond produces stretching vibration, and the absorption frequencies always is given out within the range of 1,080 to 1,360. Here, the intensity is medium, and it is always weak. Then we have another one that is nitrogen-hydrogen bond that is produced by bending vibration, or the one that produces bending vibration. So this one has a very low range that is within 1,600 to 1,550, and the intensity here is medium. Then when we come to the alkane is having two kinds of the functional group which we shall always analyze or interpret. We have the carbon-hydrogen bond that produces stretching vibration. Then also still we have the carbon-hydrogen bond producing the bending vibration. The carbon-hydrogen bond that produces stretching vibration will always have a range from 2,850 to 3,000. So meaning that this carbon-hydrogen bond that occurs by stretching or produces stretching vibration, it always occurs around 3,000 and below. and the intensity is always strong. Then the carbon-hydrogen bond that produces bending vibration, it occurs within the fingerprint region, that is 1,350 to 1,480. And here it is variable because it always produces several peaks or overlapping. So the carbon-hydrogen bond, that one occurs as a result of the sp3 carbon-hydrogen bond absorption. So that is produces the vibration, which is always less than 3,000. So now, sometimes we talk about this compound. We said if a compound has a vinylic aromatic acetylene, that is vinylic aromatic, then the carbon-hydrogen absorption is greater than 3,000. But now, for the carbon-hydrogen bonds that belongs to the alkanes, it will always have the absorption frequencies from 3,000 and below, or the frequency less than 3,000. Then if we go to the alkenes, for these alkenes is having two kind of functional group which we are supposed to interpret. We shall have the carbon-hydrogen bond, and then we have the carbon-carbon double bonds. So for the carbon-hydrogen, we shall have two kind of vibration. We have the one which produces stretching vibration, and then we have the one which produces the bending vibration. So the one that produces stretching vibration will always give out the absorption frequency within the range of 3,010 to 3,100, and that one produces a medium intensity. Then the carbon-hydrogen bond that produces bending vibration will always have absorption frequency ranging from 675 to 1,000. And here the intensity is always strong. Then we have the carbon double bond, that is carbon-carbon double bond, produces stretching vibration. And here the absorption frequency ranges from 1,620 to 1,680. And here the intensity varies, does not remain fixed. It is not strong, it is not medium, it is not weak, but it keeps on varying within the three: weak, mediums, and then strong. Then we have aromatic. Within the aromatic, we have the carbon-hydrogen, which produce stretching vibration. And here the range is within the 3,000 to 3,100. This one is produced as a result of the sp2 hybridization, and the intensity is medium. Then we also have, still in aromatic compound, we have the carbon-carbon double bond that produces stretching vibration, and the absorption frequency always occurs within the range from 1,400 to 1,600. And here the intensity is medium. It produces some multiple bands. There shall always be some multiple bands which is produced within the peaks. So when you compare the carbon-carbon double bonds of the aromatic compounds and then carbon-carbon double bonds of the alkene, the one for the aromatic compound is always lower than that of the alkene. So the one for the aromatic compound is low. It's because of the conjugation, because the electrons within the double bonds of the aromatic compounds are delocalized all over those carbon atoms. So it sometimes produces an effect that lowers the absorption frequencies. So we have the alkyne. Alkyne is having carbon-hydrogen bonds, and then we have the carbon-carbon triple bonds. So all this one produces stretching vibration. Then the carbon-hydrogen bonds of the alkynes produces it is produced by sp hybridization, and the absorption frequency always occurs around 3,300. Then here the intensity is strong and sharp. Then for the carbon-carbon triple bonds, the intensity, that is the absorption frequency, occurs within a range of 2100 to 2260. And here it is not fixed. The intensity is variable and it is always not presented in symmetrical alkyne. Then we have the alkyl halides. The alkyl halides, that is when the halogen atoms are attached to the carbon directly. All of them produce stretching vibration. Then the carbon fluoride, that is carbon fluoride bond, has absorption frequency that occurs within the range of 1000 to 1400, and the intensity is always strong. Then the carbon chloride bond, it produces the absorption frequency within the range of 600 to 800. Here the intensity is strong. Then we have the carbon bromide bond. It produces, the absorption frequency occurs within the range of 500 to 600, and that is strong. Then for the carbon iodide, it is within a range of 500. That is, the intensity is strong. So when you look at the absorption frequencies keeps on decreasing depending on the kind of the halogen atom. So it decreases based on the electronegativity of those compounds. So the fluorine being very small and having high, it is having higher electronegativity, it will always form a strong bond with the carbon, and therefore it makes the force constant to be always high. Now, if the force constant is high, the absorption frequency will always be also high. So the absorption frequencies keep on decreasing based on the electronegativity of the halogen atoms. Then we go to the amines, that is imines and the oximes. All these one contain the carbon double bond nitrogen, and this carbon double bond nitrogen produces stretching vibration. And the absorption frequencies for this carbon double bond nitrogen lies within a range of 1690 to 1640, and the intensity here is ever strong. Then we have this sulfur hydrogen bond, that is sulfur single bond hydrogen, to produce a stretching vibration. And here the absorption frequency ranges from 2550. Then we have the sulfoxide, which is having the S double bond O to produce a stretching vibration. Then the absorption frequency here occurs within the range, or occurs around 1050. So this one lies within the fingerprint region, which sometimes is not interpretable. Then also the one for the carbon, that is alkyl halides. All the bands, all the spectrums lies within the fingerprint regions, which we shall not always interpret for the beginners. So, but as time goes on, you can learn how to interpret them. So when you use our correlation chart very well, you will be able to interpret and identify the functional group which is present in the compound. So as we shall be going to look at how to interpret the IR spectrum, we shall always be using this IR absorption correlation chart, which contains all the kind of the absorption frequency that corresponds to a particular functional groups. Thank you for watching. Thank you for watching. Subscribe so that you can get other discussion. The moment we discuss, you can be able to see what we have discussed. Thank you so much.